All right, so hopefully it should be recording properly. Just gonna try to get it all into one video and show what I did for my ANSYS Fluent assignment for Professor Osby. So I opened up Workbench and then I'm just gonna go to Fluid Flow, the Fluent one. Sorry. And then I'm just gonna open geometry, and this is where we can make our wind tunnel. So once it loads up, I'm just gonna go on the XY plane so that I can draw in 2 dimensions. I do want to go to inches though real quick, because that's the way this project was given, so make it easier to sketch. So mostly just using line tool here. I want to keep it pretty centered. So I'm just going to start by making a long horizontal line and then modifying its length using the ruler, the general ruler tool, so that it's 93 inches because that's the total length of the test section requested. Now it's going to like fly over to the right side. That shouldn't be a big deal. If we go to constraints, we should be able to make, there we go. We made the origin our center. And I think now we can continue. One more thing that would be nice to do though, let me see. Well, actually, I guess it doesn't. I guess I should have done it differently. I actually want this not to be the middle exactly. Let me delete this line real quick. I'll just do this. So I want to center the middle of the test section in the middle, the vertical middle of the wind tunnel. So by doing it this way, it should make it easier later on when we go back. So this should be 45. And draw one more line. And these are just for reference. I am going to be deleting this after. So this is going to be, oops, dimensions. Where is it? 48. All right, and then this way, both our vertical and test section center should be on the origin, or I guess using the X and Y planes. So now we can go back and make a line. I'm just gonna make it a little further, just so I can use constraints, because I'd rather do it this way. And if I set that as midpoint, then it should all remain centered around it. This will tell you how well defined your sketch is. Usually it'll be in this area. If you don't see it now. Oh, I think I would have to go to like a draw. But yeah, when it's a blue line, there we go. You can see that it's well defined. But later on, when we delete these reference lines, it will be under constraint, unfortunately. So we'll make another horizontal line right here and right here. And we'll just modify one of them. This is 15, the length. And then make sure you guys put in whatever dimensions you need, but for this year's assignment, this is all. And we can also put a constraint to make these equal length. Oops. And so that should make them the same. The next thing I'm gonna do is I'm gonna draw out from here. This is gonna be another reference line, it just makes it easier for me this way. And we can decide the height of this real quick. Oops. Let me just check. So our test section height is 6 inches, so it should be 3. Because that's half of it, and it'll be going either direction. And then from here, the entire length of the test section is 12 inches, but since this is the halfway point right here where we set it, we can also define this as a, well, I guess we can do the whole thing. Let me delete that real quick. So we can do dimension that as 12. And then give it a constraint and choose that point as the midpoint. Perfect. And we can mirror the same thing on the other side real quick, just so that we have it. Now I was playing around with like using more constraints and mirroring stuff, but it never turned out as well as I wanted. Something would always go wrong in the end. So that's why I'm just gonna keep it pretty simple and just do everything kind of manually. That one's not horizontal, so you can just make it horizontal. And then for the length, yeah, you can do equal length for these two. And since one of them is already defined, it shouldn't matter. And then I'm going to do midpoint, this point, and this line. And then from here, we're going to want to connect this point. It's our contraction chamber. So there we go. And based on the selection tool, they should already be attached properly. They should be coincident. If you do want to define them properly, then you can just give them a dimension, in which case they both get fully defined. So now they're all in blue. From that point, we only have a little bit left. We're just going to draw a line kind of sticking up and another one. And then we know that our length from lines, I guess, should align with this. So I just kind of I did the kind of same thing as earlier. I drew a line, and I'm sure there's better ways to do it, but the one thing I did was I just where's the midpoint? There we go. I made this the midpoint for this line, and then we'll make these coincidence in a second, or we'll make it, coincident with the line. But first we'll define the angle. So if you go into dimensions, it should be an angle tool. Now I could have added another line right here and made it easier, but then when you delete it, it's just on dimensions. I'd rather keep as many dimensions as possible. There's a couple ways you can do this. I think if I go this way, then I gotta go like 177 because we want an angle of 3. Yeah, so you kind of want the opposite because it's just the way the tool works in this case. So you can do the same thing right here and click these. And then this should also be, where is it? 810. Should be like, this one might be like 183. I think it's the opposite. Yeah. And then the last thing you want to do is you want to add a constraint. So you want this, oops. Skip real quick. Sometimes I have trouble selecting the points. I think it helps if you select a tool that might look for points. So make that coincident and then make that coincident, and now it should attach completely. You can also go back and make these two coincident, and yeah, that's it. And since they're equal length, I'll just cut it down. Everything should be dimensioned and drawn at this point. So what I would do is I guess I would just go back and delete this line, and then delete this line. And if you guys use any other reference lines, make sure you remove them at this point. And this should be our full drawing. As you can see, now it's under constraint. I just couldn't find any construction lines on here. So I didn't know any way to leave any lines that wouldn't actually affect the end product. So I went about it in this manner. If I remember correctly, you gotta create I went to concepts and then it was, oh no, that's wrong. Cancel it real quick. Oops. I want to go to concept. Oh, what a mess. Let me just I don't want this anymore, so maybe I can delete this. Yeah. Okay. So we'll go back to sketch one. This is our sketch. Oops, I left this line here. Let me go back into sketching. Okay, now we should have no more lines running through the center. Sorry about that. Okay, so I'll go back into modeling. I press line from sketches back, so I'm going to do surface from sketches. So you're gonna do that, and then you're gonna click your sketch, sketch one, and then just press apply, and it should create a surface from it. Let me see. Oh, press generate. Sorry. Yeah, press generate up top, and then yeah, now you have a surface from your sketch. It's a wind tunnel, pretty basic one. If you want to make it a little more maybe like efficient, you can fill at the corners a little bit. But this is just a simple tutorial on how to get the general idea. So at this point, you can actually close it. By the way, I was building it in Design Modeler, the sketch, and not Space Claim. Keep that in mind. I think it's nicer to do on Design Modeler, but up to you. So I'm just gonna go normal to that. And then we wanna look at our mesh. So it should already have a mesh on it. Well, we can generate one. And then there we go. So right now, this is a mesh that you could technically use, but what I found to work better is if you insert a method, you can apply this geometry, you just gotta click it. And then right now it's on quadrilateral dominant. Triangles seems to be the consensus for this project. And you can also create the mesh size. So we are in meters. So we'll go 0.01 maybe even a little smaller, let's see. Okay, that's pretty small. Could go a little smaller, but I think that should be small enough for this project. But yeah, as you can see, once you press generate mesh, these are all triangles now rather than squares, and the size is going to way smaller. This is how you control the size. If you do want to make it smaller, you can go ahead and do that, but I'm just going to leave it at that. So mesh is generated, just going to close that out. We can update it real quick. Should have a check mark by it when we're done. So I'm either missing a step or I just need to update it. All right, there we go. So it has a check mark. And then we're going to move into setup, I believe. So we can do double precision, and that shouldn't matter too much, honestly. I guess this depends on your computers. So this is kind of the messy part, so bear with me. I'll try to get all the information to you. It's still loading in. Oh, I forgot something. Give me a second. Yes. So we're gonna go back to mesh. And this is pretty important. We have to name our surface, like our boundaries. So we can click on our model, and then you're just gonna click on like an edge, like this one right here that I clicked on, and then you're gonna press N. It'll pull up the naming selection, and you can call this one velocity inlet. Okay. And then you can double click. Last time. I guess you can select them each, shift click them or control. So you can select all of these, and they're selected in green. It's a little hard to see. And then you press N again, and you're just gonna call this should be, I think, wind tunnel wall. And then you can just click this and name it. That should be the last one. This should be pressure outlet. And now if you go to name selections, it should show you velocity inlet, wind tunnel wall, and the pressure outlet in the back. So now we can close this. We're going to update the mesh again. It should be the same mesh, but now it has the names labeled. All right, now we're gonna go back into setup. Same thing that we selected earlier. I am running this on a laptop, so it's struggling a bit. If you have a desktop computer, definitely use that when running this software. Some missing pieces that match their names panel. Let's see. To make mesh compatible with settings, please visit Match Zone Names panel. File recorded mesh operations, edit incoming zones. Okay. File, recorded mesh operations, match zone names. Okay, so missing zones, wall surface. Let's see. Let's see if this works. We're gonna go into general, I think. Or not. Oh, okay. If you go into models, we'll turn energy on. And then for here, for the viscous setting, we're gonna go into K epsilon. And I think we're gonna leave all these settings the same. This is just what I did. Yeah, that should be it. And then we can make sure that our fluid material is air. We can check our surface body fluid. It should also just be air. Yeah, material name air. And then for the boundary conditions, this is where we want to change our inlet velocity. So depending on what project you have, you might be given the inlet velocity, or if not, you might have to back calculate it using formulas for like dynamic pressure. So for me, I think the first one's like 0.23 something for the 10 Hertz situation. You would just plug it in. This would be the test section velocity, and then you would have to like go backwards in order to find the inlet velocity. It's not the same one from the formula. I did want to change units for length to inches real quick. And let's see, mesh interface. I think that's about it. We want to initialize now. I guess Fluent. Wait, let me put it's only on 10. I'm gonna do maybe like 80. So we're gonna rerun that. And after we initialize it, we can run our calculations. I'll probably do like 120 iterations, and that should be it. This part takes a while, so definitely struggles a bit running it. It'll usually like pause halfway, or it'll pause at like 99%. But we'll see. My computer's almost crashed on me a couple of times during this step. Maybe I'm running too many iterations, but I kind of just want to see that the results converge. And since it's like flattening out pretty nicely, it's not bad. But you can see towards the end, it's still oscillating a decent amount. So it's not completely converged, but it should be good enough. And then here we can start working on our contours and all that. So the first question was, you have to do this for each of the frequencies. We're doing 10, or a velocity that's close to the 10 Hertz one. So the first step is to get the velocity, static pressure, total pressure, dynamic pressure contours in the wind tunnel. So what you're gonna wanna do for that is you're gonna wanna select all of these. And I put coloring on banded. I don't think that matters, honestly. And we can start with pressure. So you set the pressure setting, you make sure it's on static pressure, and that'll be our first one. And then you're gonna compute it. Here you can see your minimum and maximum total pressures. You might need this for the fourth bullet, for example. I'm not gonna go over that in too much depth. That one, I did use Excel for it. You can either import, in order to solve this one, you can either import the data from Fluent, or you can use the minimum and maximum static pressure values, and you can calculate the dynamic pressure from the velocity that you have. But yeah, if I display it, you should see right here, this is our velocity, or sorry, this is our pressure contour. You can move this thing around wherever you want. You can also, if you double click it, you can change it. So right now it's exponential. You can change it to float, which would make it, regular numbers. You can align it. I like to align on the bottom, and then you can change the ratio. But yeah, you can align on the bottom like that, and then it's pretty nice. It kind of goes lengthwise with it, but that's not really that important. Then after you do that, you can take a picture of it. You can either use this copy tool right here. Oh no, sorry, this one right here. So take a picture of the whole thing, or you can use the snipping tool. I personally just use the snipping tool. Then you can look at your dynamic pressure. It'll also show you the minimum and maximum values of your dynamic pressure. You might need that. And of course, you can look at your total pressure. Now, the total pressure should be pretty red because it's dynamic plus static. In this part, it deviates a little because you have that angle that's going on. So I guess it's just causing a little bit of a separation. But yeah, you can move all this around. After that, you might want to do velocity. And you just need the velocity magnitude. You see the maximum velocity is 1.1 meters per second, and that's our velocity onto a graph. Now I think if you increase the mesh size, then it'll look a little different. But if you do, let me see, same thing. But yeah, that's basically what I did for that section, more or less. And after that, you have to plot the variation of velocity, static pressure, total pressure, dynamic pressure along the wind tunnel center line. So for this, it's a plot. So you want graphs, the professor. So you don't need these anymore. And you can go into your plots right here. And then you want to go into, I think, XY plot is what you want to click. Yeah. So right now, X is 1, Y is 0. So that just means it's like a regular XY graph. If you want to flip it, which you're going to have to for the third step, you're going to put Y1, X0. But for the moment, we're just going to select, I think, everything but wall surface. Let me see. We'll try that real quick. See how it looks. Let's do total pressure because that's usually the one that's a little more fidgety if you do it wrong. Okay, so that's not what we want to do. What if I select this too? No. That's a little more like it. Oh, I forgot. So we want it along, I was confused. You require to plot the variation along the wind tunnel center line. So what we're gonna do is we're gonna make a new line. And since we centered our graph properly, all we're gonna have to do is Y0, and then we're gonna need to do the 45 in one direction. It was negative 45. And then the 48 in the other direction. And this should be our proper new center line because you're just running it from edge to edge on the x-axis. So let's see. We'll know in a second if this is right. Yeah, so that makes sense. Weird little bump right here, but we are looking at a pretty small area. Not sure exactly why that may have happened. It may just be some of our geometry may be a little off, but in my actual report, it was a straight line. So this one might just be a little off because I'm not sure exactly why, but maybe a little mistake in either in the geometry or this part. But this looks pretty good. You can show what line it is here. We could call it also center line. You can label it differently, but this is a static pressure. It makes sense. It's gonna start high at the beginning of the test section, and it's gonna course go lower as dynamic pressure becomes more dominant in the as velocity increases. And then dynamic pressure should be almost the exact opposite. Yeah, there you go. And so it is weird that the plot for total pressure is not a straight line because these are very similarly inverse. But they do look good, these graphs. And then you can also look at velocity. And yeah, that's velocity. Velocity should look really similar to the dynamic pressure because if you guys remember the formula, they are like related directly, proportionally. So as velocity increases, dynamic pressure increases and static pressure decreases. So that's it for bullet number 2. You would do the same for the 30 Hertz situation and the 50 Hertz. And then you want to plot the vertical velocity. So this part's a little more confusing. You're going to make a new plot. That's how I recommend. And you're going to make a new line. And we can call this one whatever. Center of test section because it's going to be the vertical center of test section. And that one we placed at X is 0, 0. It's the origin, makes it easier for us. And then it was only 3 in each direction, X and Y. A little bit of a mistake right there on me, -3 to +3, if y'all remember. So that's our new line that we're going to be using, center of test section. And we're going to want to flip these, I think, now, because it's going to be a vertical line. So displacement is going to be in the y direction. So pressure, here's our static pressure. Let me see. Let's see what the dynamic pressure looks like before we make any decision. The dynamic pressure looks fine. This is how it looked when I was graphing it. We are just measuring the middle of the test section, so you have to remember that the center of the test section is the highest velocity, and so at the bottom is going to be a lower velocity than in the middle of the test section, vertically speaking. Is going to be almost the same velocity, the whole center area, and then as you get to the top of the test section, the roof, the ceiling, it's going to get lower. Static pressure should be the opposite, but again, we're not working with that many points. It's a little harder to tell perhaps, but it's it's all relative to, you can see these numbers are super small, so it's all relative. The static pressure is just super low, so it looks like a lot of variation, but it's such a small number, it's really not. And total pressure might be a little bit funky for this. Yeah, it's a little bit weird because again, like the static pressure is super low in that section, and so it's mostly just measuring, it's gonna be almost proportional to dynamic pressure because in a test section, the velocity is so high that static pressure is almost like non-existent relative to the rest of the test section. And then of course, you can look at your velocity contour, and that should be similar to your dynamic pressure, or sorry, not contour, plot. That should be similar to your dynamic pressure plot because when you're near the bottom test section vertically, then it's going to be lower because it's like it has the wall. And near the top, same thing, it's hitting the wall, so it's going to be lower as it gets there. And then the center is going to be almost equal because it's just the velocity is coming in streamlined. That should be it for that. And then, like I was saying, for bullet point number 4, I'm not going to go into full detail on how this one worked out, but basically you're going to have to, because I'm just doing the Fluent section I'm demonstrating, but you have to go into, well, you don't have to, but what I recommend is going into Excel, getting your values from Fluent. You can either export them or just write them down. There's a lot of ways to go about it, but you just need your pressure change in the contraction chamber. Now you can also remember that the contraction chamber, the inlet of it, I don't know if you can look at our geometry right now. Maybe it's like here. Well, I don't know how to check the model right now, but basically in the entrance to the contraction chamber, it's going to be like almost entirely static pressure. So that's going to be your max static pressure of the whole wind tunnel. And then the minimum, the exit static pressure is going to be at the beginning of your test section. So that's going to be like your minimum because that's where velocity is highest. And dynamic pressure in the test section, you can calculate that based on the velocity that you are given. So you have this formula right here, V test section, and then I think it's 1/2 rho V squared should be your dynamic pressure in the test section. This is the velocity for the test section. And then to plot the linear regression line, you just go into Excel, you create the plot with the 10 Hertz, 30 Hertz, 50 Hertz frequencies and their values for it. And then you plot the delta pressure values, and it will be a straight line. For me, it was a perfectly linear line. And you can also get the equation from Excel in order to calculate the calibration constant. Yeah, if you all are doing this project, good luck with it. And hopefully this tutorial wasn't too confusing. I just want to show some of the stuff that I did in order to finish this project.